So this is the second chapter from AICE, and it's about the modulus function. Now, modulus is an AICE word, so this is actually something you've seen before in Algebra 2. It's actually absolute value, so just make sure you're aware of that word. Now, the things that you have to be able to do in Chapter 2, you can see up on the board there, and you might want to pause the video and just read through those yourself. But a lot of those things you should already be able to do from Algebra 2. Now, what we're going to take a quick look at is a reminder on how to solve a few absolute value equations. So the absolute value, the key is the two little lines here. And just a reminder what the absolute value does, it takes anything that is negative and makes it positive. So the absolute value of -5 is 5. What it doesn't do is it doesn't switch the sign. So if I said the absolute value of 5, then that's still 5. So it doesn't necessarily switch positive to negative, but it does make anything that is negative positive. Also, I put a little reminder up here that wouldn't be given to you. Check for extraneous solutions. Whenever you solve an equation, remember to plug back in just to make sure that it is actually a legitimate solution. So the key thing with this is you have to split the problem into two. So once you have the absolute value of something equals a number, then you say x plus 7 equals this, or x plus 7 equals the negative of this. Because if we have the negative 11, when we do the absolute value, we're going to end up with 11 anyway. So we just split it up into two equations, and then we just solve each equation independently. And then if we have time, we can plug back to make sure this works. So 4 add 7 is 11, absolute value of 11 is indeed 11. Negative 18 plus 7 is negative 11, and the absolute value of negative 11 is 11. Then one you've got to be careful with is this one here. It's very tempting to want to split it up like you did in the last question. Say x plus 7 equals -5, x plus 7 equals 5. Remember the definition for absolute value. Anything that's negative is going to become positive. So actually, we can never have an absolute value that equals -5. So this is actually our simplest question of all. You can try doing that, but it won't work. It's actually just no solution straight away. Now, if you did check for an extraneous solution, you would know that this doesn't work anyway, because you would end up with something that's not -5. You'd end up with +5 here. And the same here, you'd end up with +5 as well. 5 doesn't equal -5. So be careful in those questions where you have something that's equal to a negative number. Now, we can make the questions a little bit longer, but the idea is the same as the first example. What we're trying to do is we're trying to solve for the absolute value. So we can bring things to the other side. So instead of adding 1, we can subtract 1. Instead of timesing by 2, we can divide by 2. And then now, once we've got the absolute value equals a number, we can go ahead and split this up. So x minus 3 equals 4, or x minus 3 equals -4. Solve each equation independently, and then we've got our two answers. If you have time, plug them back in, just to make sure it's not an extraneous solution, and these ones are perfectly okay. Now, our last one is an absolute value equals, but something with x in it this time. And these are really the ones where you've got to be careful. And this is where you're probably going to get those extraneous solutions. So we're trying to get the absolute value by itself again. So we're still going to bring things to the side. So instead of adding 1, we're going to subtract 1. Instead of timesing by 2 here, we're going to divide by 2. Now we can go ahead and split this up. Now this we're going to be extra careful with as well. We can say it equals 3x plus 3, or we can say it's the negative of all of this expression. So in other words, if we distribute the negative here, -3x minus 3. So you've got to be a little careful with this, and for that reason there, when you split it up, you might want to say it's the negative of, put parentheses around the whole thing to remind you that everything is negative. And then, as just before, go ahead and solve those equations, and we've got our two answers. Plug them back in to check that it works. And actually, if you try -3, it turns out not to work. Now, you want to plug back into the original one. So -3 take away 3 is -6. The absolute value for that is 6. 2 times 6 is 12, plus 1 is 13. But when you plug -3 into here, you get -18 plus 7, and that's clearly not going to work. That's clearly not exactly the same thing. You can check with 0, and it will work just fine. 0 take away 3 is -3, but the absolute value of that is +3. 2 times 3 plus 1 is 7, and clearly 6 times 0 plus 7 is also 7. So we do have our solution there. When it comes to doing inequalities, it's pretty much the same procedure. And there's just a couple of extra steps you have to remember. When you split this up, you split it up into 2. You make one positive and one negative, but the second equation you must remember to flip the inequality. And then you solve each equation independently. And if you check with the original question where it said equals, you can see you end up with the same answers here. Also, a common thing you should look for is make sure one of your answers is greater than and one of your answers is less than. So that's just a little summary of solving absolute value equations, which you should have covered in Algebra 2. Now, when it comes to graphing absolute value equations, if we forget how to do this, we can always create a table of values, create some x values, plug in each x value into the formula, and then see what y value you get. So the absolute value of -3 is 3, add on 2 is 5. Do that for several values, and then you can go ahead and plot them. Same idea if we did subtract 1. Now, the ones I've put here, I haven't revealed the answers, so you might want to pause the video at this point, have a little try, substitute in, just to make sure you get the correct answer. Notice the difference between this question and this question is where I put the +2. On the first question, I put it outside the absolute value, but on this question, I put it inside the absolute value. So go ahead, pause the video, and see if you can come up with the answers. Okay, so let's have a look at our answers here. And hopefully you managed to come up with those fairly accurately. Now, there is another way you can do this as well. Also, from Algebra 2, you should remember that absolute value graphs are V-shaped, and you might well have seen this formula as well. Y equals A times X minus H plus K. Now, the number at the top affects the slope, or the steepness of the V, so the bigger the value of V, the bigger the value of A, the steeper the V is going to be. If we have something like a half, then it's just going to flatten out. Also, if we have a negative, then it's going to turn the V upside down as well, or really it's going to reflect it in the x-axis. The K at the end moves the graph up and down, so if it says +2 at the end, it moves the V shape up 2 places from the origin, or if it says -2 or subtract 2, that means it moved the V shape down 2 places. Inside the parentheses, it moves the graph left and right, but it's the opposite of what you think, so in other words, it's a horizontal translation. So if it says x +2, what it's actually done is it's moved it to -2 on the x-axis. Or if it says x -3, then it's actually moved it 3 across to the right. And that's really why the negative is here, just to remind you that you're going to do the opposite. Also, we have some slightly different graphs than what we did possibly in Algebra 2. So we could have graphs of a function, we could have the graph of the absolute value of the whole function, or we could have just the absolute value of x. And there are a few rules that you need to learn in respect to this. Now, first of all, you have to be able to draw the function. So 2x plus 1, this is slope-intercept form. So we start from 1 on the y-axis. A slope of 2 means we go up 2 and across 1, which would give us this line here. Now, when it comes to drawing the absolute value of the whole graph, remember that the absolute value means that we're not allowed any negative values. So once we go below the x-axis, all these values are negative and we're not allowed, and we're going to make them positive. So where it's -1 here, that's going to become +1. Where it's -3, it's going to become +3. And what it actually does to the graph is anything that is below the axis gets reflected over the x-axis, and that becomes our actual graph. Now, if we just have the absolute value of x, then we don't have to worry for anything that's positive, because the absolute value doesn't do anything to that's positive. So this first part of the graph stays just the same. Now, the second part, though, we're not allowed any negative values. So if I was to plug -1 into this formula here, well, actually, I'm going to plug it into here. I'm going to get the absolute value of -1, which is 1. 2 times 1 is 2, plus 1 is 3. And what you can see is at -1, it goes up to 3. What actually happens is we get a reflection in the y-axis. So if we just have the absolute value of x, then you draw the first part of the graph from x is greater than 0, and then we reflect it in the y-axis. Now, a question I also like to ask here is to link it back into other things that we've learned is your trig graphs. So at this point, you should make sure you can remember how to do sine, cosine, tangent, secant, cosecant, and cotangent. And actually, that's part of your exercise for this lesson anyway. So make sure you can find those graphs. A good refresher, but also to make sure you can apply those new rules to that. Now, we also did a little exercise where we got people to come up to the board and actually try drawing these graphs using the property. Now, you can see that they've already been drawn on. This was the answers from the class that they provided. So let's just make sure we can see where these answers actually came from. So the absolute value of x we know is going to be that V shape. And we know it's going to go at 45 degrees because it's got a slope of 1, or positive 1 for this side and negative 1 for the other side. So at the plus 3, all that does is, as it's outside the absolute value, it moves the graph up the y-axis. So move up 3 places, and then we just draw in our V-shape. If it says minus 2 at the end, then it means the V-shape just moved down 2 places, so we can find our vertex, and then we can go ahead and draw our V-shape. This time it's inside the absolute value, so that means we're going to move it left and right, a horizontal translation, but the opposite of what you'd think. So negative 1, actually it moves it across to positive 1 on the x-axis. Then we just go ahead and draw in our V-shape. X minus 3, same idea, it's inside the absolute value, so it's a horizontal translation, but the opposite of what you'd think. So instead of being negative 3, it starts at positive 3, and then it's just our little V-shape drawn in. This time we have a number in front of the absolute value, which affects the slope. So this time we've got a slope of 2, so up 2 across 1, and then draw that line in. And then the same the other way, up 2 but across 1, and then you can draw that slope, which is actually going to be negative 2. 1/3 x, so same thing, this is the number in front of the absolute value, so this is the slope. So a rise of 1 and a run of 3 would put us there, and we can draw that line in. And the same the other way, up 1, and then across 3, and then draw that line in. And hopefully this would be a straight line. Just scroll down a little bit. So this time we're starting to add a couple of components to this picture. So I know I've got to go 1 to the right because it's inside the absolute value. But at the end it says plus 2, which means I have to go up 2. And once I've found my vertex, then I can draw that nice V shape in. X plus 2 minus 4. So I'm going to move 2 to the left. Negative 4 at the end means I'm going to move down 4 places. And then I can go ahead and draw in my V shape. Slope of 2, but also we're going to move down 5 places first. So 1, 2, 3, 4, 5. And then up 2 across 1, up 2 across 1. And then we can draw in our V shape. This time we've got 3 components to this. We've got a left, right, and up, down, and also our slope changes. So 2 to the left and 1 down. 2 to the left, 1 down, so we found our vertex. And then this part's the slope of 2, up 2 across 1, up 2 across 1, and then we can draw in our lines. Number 11. 3 parts again to this. 1 to the right, 3 up from the origin, 1 to the right and 3 up. And then our slope is 1/2, so up 1 across 2. And same the other way, up 1 across 2, and we can draw in our V shape. So this is much quicker than doing a table of values, and hopefully this is the way you'll go for. You can see it's moved up 3 places, but this time notice we've got a negative at the start, which turns the V upside down, or reflects it in the axis. So there we go. Same idea, 4 to the right, but as it's negative, I'm going to draw the graph upside down. 3 components to this one, or 4 I guess technically. 2 to the left, 2 up to give us our vertex, and then a slope of negative 2, so down 2 across 1, and then the opposite, down 2 across 1, we can draw our V in. The negative also tells us it's going to be upside down, so that should be a recognisable part of that graph. And I think if you understand those first 14, you could probably figure out the rest of them equally as well.